We can't always control nature's forces, especially fluids. Fluid piping in a hydrocarbon facility is subjected to many changes in flow velocity that can cause pressure transients. Managing these pressures in such a facility is a safety and ecological challenge in this increasingly regulated field. These transients can be caused by a variety of circumstances, including valve closures or pump starting and stopping. Using modern relief suppression mechanisms to avoid loss of containment rather than traditional pressure relief valves will effectively suppress transients, avoiding piping material failures at vulnerable points. Engineers can now eliminate loss of containment using an innovative design, bladder surge tanks, instead of traditional designs such as pressure relief valves. Bladder surge tanks absorb transient energy rather than releasing fluid as a pressure relief valve would function. Pressure relief valves are not just a valve. There is considerable ancillary support piping, underground tanks, valves, and gas supply pressure tanks that make up the system and take valuable space in a plant. As pressure transients exceed the valve's set pressure, the valve will suddenly open to atmospheric pressure. The fluids continue to discharge violently at each surge peak into the containment tank. As the tank fills, hydrocarbon vapors will discharge into the atmosphere. Even though the pressure relief valve discharges, this does not prevent transient conditions in other locations of the pipeline. As a result, overpressurization can still occur in the pipeline. A more innovative and effective solution is a self-contained bladder surge tank. The bladder surge tank uses less space and constantly reacts dynamically to transient pressures with zero loss of containment. A bladder in the tank is charged with gas during installation and is monitored to determine when additional gas is needed. The bladder is the only moving part, absorbing pressure transients and allowing a nearly maintenance-free design. In the unlikely event of a breach in the bladder, the gas will still be contained in the tank to effectively function to absorb transient conditions until replaced later. Here the relief valve activates to a local transient pressure event, resulting in loss of containment. In the same scenario, a bladder surge tank is placed in the same location with its energy-absorbing gas-filled bladder. In a side-by-side comparison with the pressure relief valve, the energy-absorbing characteristics of the bladder surge tank follows the transient curve, not allowing buildup of pressure on the relief valve to occur in the first place, avoiding